Hello there, everybody. This is Mike, and we are doing a solutions video number 1 for data management. We're going to go through the 10-question quiz and give you solutions to these. Once there's enough new questions, then we will make a new solutions video at that point, and that will be number 2. But let's get on into this. So, question 1. Question 1 is fractions, and we are adding and subtracting versus multiplying and dividing. Really, for probability, you hardly ever have to subtract fractions, so we're just going to add. So in the case of today, we had 3 over 4 plus 7 over 8. So what do? Well, in fractions, there's 2 steps when you add or subtract fractions. The bottom numbers have to be the same. It's like the bottom is how many pieces of pizza the entire pizza is cut into, and they need to be in the same language. They need to be in the same denominator, or the same number of pieces. So in order to do that, we have 3 over 4 plus 7 over 8. How do we change one of these to become the same number on the bottom? So again, this number is larger, and this number goes into that number. 4 goes into 8. So the way that we can do that is when we multiply this bottom by 2, we get to 8. And then if we do that to the bottom, we have to do that to the top. So suddenly, 3 over 4 becomes 6 over 8. So if you think about that for a second, if you double the top and the bottom, you get 6 over 8. That is the same fraction. So we have replaced that with 6 over 8 plus 7 over 8. And the step 2 is pretty straightforward. The bottoms stay the same. We're still dealing with an 8-piece pizza here, except now we have 13 slices because 6 plus 7 is 13. This is different than multiplying and dividing, where those denominators, the bottom numbers, stay the same and are consistent throughout, and you add the tops. So that is how to do addition of fractions. Subtraction, you would just subtract the top numbers. Number 2 here, we're looking at the same numbers, but we're multiplying. And I know that I had written that differently, but it should be multiply. So how do we do that? Well, whenever you're multiplying, you go straight across. So we multiply the tops and we multiply the bottoms. 3 times 7 is 21. 4 times 8 is 32. It's as simple as that. You can actually see that multiplying fractions way easier than adding fractions. There's 2 steps with adding fractions, and the denominators need to be the same. Multiplying fractions, the numbers just multiply through on the top and the bottom and just get you the original. Now if there was more than one fraction, you just multiply all the numbers. So whatever all the top numbers are gets you that. Whatever all the bottom numbers multiplied together gets you the bottom number. So that is question 1 and 2. Question 3, power rule. So question 3, we have 1 over 4 squared. So 1 over 4 squared. What does this squared mean? Well, when we have, let's say, 6 squared, that just means 6 times 6, which is 36. So 6 squared is this thing times itself twice. And then you just add that or multiply that together and you get 36. So using the same logic here, this is just 1/4 times 1/4. Well, and from question 2, we know that you just multiply the tops and you multiply the bottoms. So 1/4 times 1/4 is 1/16. 4 times 4 is 16. 1/4 squared is 1/16. And that's how we get it there. Question 3. Question 4. We want to make sure that we can do percentages. So for question 4, the percentage here is 10%. So 10% of 67. Well, 67 is actually 67.0000 with all of those recurring. That is how to write this in decimal form, 67.0. But we just skip all that because it's redundant. So 10% is when you take the decimal point and you move it once to the left. 6.7. Now really think about this, right? 67, 10% of that should be 1/10. 10 of these should fit into that, and that makes sense. 10 times 6.7 gets us to 67, because timesing by 10 is going to move that decimal point back. So the answer here, 10% of 67, we move the decimal point once, is 6.7. And that is the answer to question 4. All right, question 5. You're taking two numbers and you're multiplying them together. You can do this on your calculator. In fact, that's the easiest way to do that here. And so I did that on my calculator there, and I got 0.0121. So 0.0121. I will also note that there's 1, 2, 3, 4 decimal places to the right, and there's 1, 2, 3, 4 decimal places to the right. That's really important so that your answer should have 4 decimal places over here, and if it doesn't, because there's 2 and 2, then something has gone wrong in that question. So that is question 5. Question 6, 7, and 8. Now we've got a data set. 1, 2, 2, 3, and 4. First thing is the mean. Well, the mean is not being mean, but is calculating the average. Average is another word for that. The way we're going to calculate that is we're going to add these all up. 1 plus 2 plus 2 plus 3 plus 4. So what do we get there? Well, we get 3, 5, 8, 12. Did I do that right? 3, 5, 8, 12. So if we add those all up, that gets 12. And then we divide by the number of numbers. So there's one number here, 2, 3, 4, and 5 numbers. We divide by 5. So the average, or the mean, is 12 over 5. That is the mean for this data set. If we wanted to translate that, it would be 2.4 if you made that, if you calculated that using your calculator. So 2.4 is the average of those. Now that was the mean. Now the median, this is another statistical measure. The median is middle. So the middle number is literally, counting in from the outside, here. It is 2. So the median is 2 in this case. But I also want to talk about the mode. And the mode is the most frequent number. So by most frequent, I mean literally the number that repeats the most. So we've got only 2 is repeating, and so the mode is also 2. So again, the 2, there's 2 2s. There's no other repetitions that are more than that. The mode is also 2. So you can do that for any size of data set, and we'll be doing more of that as we go. and we'll be making those more complicated also as we go. So we're also doing probabilities. So those were 6, 7, 8. So let's work on 9. Question 9. We're going to flip a coin. So standard-wise, it's 50-50 that it's heads, and it's 50 that it's tails. You can express that as 50% versus 50%. You can also say 0.5 and 0.5. You could also say 1/2 versus 1/2. It's half that it's heads, half that it's tails. But now I'm giving you an extra piece of the puzzle here, where we're saying landing on its edge. So this is an interpretive answer. So you might have your own understanding of how this works, but I would say the probability of a coin landing on its edge is, let's say, 1 in 10,000. So if I flip it 10,000 times, depending on the table, depending on the type of quarter, I'm going to say 1 out of 10,000. Well, that means that I have already dedicated this much of the probability in the probability tree to 1 out of 10,000. Now this is the edge. So if that probability is already dictated over there, then these have to share the remainder of the probability. So let's call this one heads, and let's call this one tails. Well, that means between the both of those, I have 9,999 flips where it, because those are the remainder out of 10,000, that can go heads or tails. And so if I actually divide that in half, and I'm just going to do that on my calculator here. So I do 9,999 divided by 2. Then I've got a 4,999.5 out of 10,000 chance of this, and a 4,999.5 out of 10,000 option of having heads or of tails. And so what is the probability that it lands on the upright edge? Well, I'm going to say, let's say 1 out of 10,000. And question 10 was calculate now the real probability based on this edge that I'm saying. Now the rest of the probabilities are split between these two, tails and heads. And so the probability of me landing tails is 4,999.5 out of 10,000 flips. It's going to go to tails. And that one extra time that leaves space there, it goes on its edge. So again, probability situations are best when you map out the probability options, and then you draw these trees and you look at what are the options available, what are the probability of each of those, and they should all add up to 1. So make sure that all of these equal 1, because unless you have some probability that it doesn't happen at all, but that should really be another branch. So hopefully that's helpful, and I will leave it there.